Hey friends, this is Chris again. Hopefully you've seen my Docker video. And at the end of that video, I asked the question, how do we make sure that we can deploy these Docker containers in a consistent manner? Well, one solution you probably heard about is Kubernetes. Now, Kubernetes has a very intimidating name. You may have heard that Kubernetes is complex. It's actually not really that bad. And my goal this morning is to make sure that you understand the basics of Kubernetes for deploying your Docker containers. It's actually very simple. So today I'll be considering a sample project that I have in my GitHub. You can go and clone that GitHub repo. I have the link in the video description below. This repository has a pretty good README that more or less covers everything that I'm going to cover this morning. One thing I'll kind of go over very quickly is how do you even run Kubernetes on your local machine? Well, if you're running Windows or Mac OS and you have Docker Desktop running, all you have to do is go into the Docker Desktop preferences, click on the Kubernetes tab, select Enable Kubernetes, and then apply and restart, and you're off to the races. You then have a development Kubernetes cluster running on your local machine. On Linux, it's a little more complex. For this video, I'm running Ubuntu 20.04, and I've decided to use micro K80s or micro K8s. And I installed that via a snap install. Once you've installed it, you need to add your user to the micro K8s group. So there's a lot of other options on Linux, but that's just what we're going to use for this video. And to get it started, I'm going to start my micro K8s cluster, micro K8 start. Okay, so my local development cluster is up and running. So I'm going to have a look at my cluster. The way we interact with Kubernetes is via the kubectl command, and you'll be getting very familiar with that during the course of this video. But if you type kubectl get all, you'll be able to see the entire content of your development cluster. And so I don't have much running there. I've just got the standard Kubernetes service running. Well, if you've cloned that GitHub repository that I mentioned, what I have in here is there's a subdirectory called echo service. And in the echo service, there is a Node application. This application is extremely simple. You can start it locally without even running it through Kubernetes. I'm going to go into echo service. I'll type npm install. So of course, the npm install gets all the dependencies, and then I can type npm start. And my service is running on port 8080, and there isn't a lot to this service. So I'm just going to install this extension in VS Code called Thunder Client, which helps me call REST APIs. And there it's installed. And we'll create a new request here, and it will go to localhost 8080. And I'm going to call the echo service, and I'm going to just send it a parameter something. And here we get the response back. It just echoes back that something to me, and it tells me the name of the computer that I'm running on, the host name. So pretty simple service. You don't need to know too much about Node. I'm just going to kill it, Control-C on that. And I want to build a Docker image out of that. Now, I happen to have a Docker file here to build this thing. And I've provided a convenient script here called imagebuild.sh. I'm going to run imagebuild. Okay, so that image is built. And let's just test running this directly in Docker. So I have a Docker run script. And what this is going to do is it's going to forward port 8080 on my host into port 8080 in the running container. So I will just run the Docker run convenient script. And the echo service is up. I can go back to my Thunder client. And I can run that request again. And it still works. This time my host name is a little different. That's the name of the Docker container ID. So I'm just going to kill that. So we've seen two ways to run it. I mean, we can run it bare bones on the host directly via npm. We can run it via Docker. But what we're really interested in this video is running this thing via Kubernetes. Since you're new to Kubernetes, you're going to think that this is very, very verbose, and it is very verbose. I find the Kubernetes configuration to be more verbose than it needs to be. But there's nothing to worry about. Really, if you want to deploy something for Kubernetes, for instance, in this case, I want a deployment on Kubernetes. I just need to Google deployment YAML example, and I'll get like the basic stuff that I need to use. So let's just talk a little bit about theory. So the basic deployment unit in Kubernetes is a pod. And you can kind of think of a pod like a Docker container. It's a little more complex than that. I could have had a YAML file that describes a pod. In this case, I'm actually describing a deployment. There is a difference between a pod and a deployment. I don't usually deploy pods directly, just the raw container. I typically use a deployment, and you'll see why here, because a deployment is it's a higher level concept. It lets me deploy as many replicas of a pod as I wish. So I could deploy this service 3 times, 1 time, whatever I like. But the pod is wrapped logically in a concept called a replica set, and the deployment can give us a replica set. So if we look at the YAML for my deployment, so I've got the normal stuff here. I've got like a name for my deployment. You'll notice here there's a parameter for replicas that allows me to scale these up and down. That tells me how large my replica set is going to be. We'll talk about the selector in a moment, but you will need that. And this section here that describes the template more or less is going to describe what is going to be in our pod. So you can add some metadata to your pod, and we'll see why this is important in a moment. But it's really the spec that describes the Docker container that I want to run. So notice we're going to deploy a pod or a container. So it's going to be called Echo Service, and it's going to use this image, Echo Service, and the tag is latest. It's going to open up port 8080. Now I'm just going to delete this volume mount section because we won't be dealing with that just yet. So first of all, if you're running on Mac OS or on Windows and you're using Docker Desktop, you build that Echo Service image, you can use it directly in Kubernetes. Since I'm running on Linux and I'm using micro K8s, in my image build, I need to make sure that I actually export my Docker image and import it into the micro K8s context. So I'm just uncommenting those 2 lines. I'm going to rerun image build.sh. Okay, so that's a step that only I need to do because I'm running micro K8s, but now micro K8s is aware of my image. I'm going to deploy this deployment to my Kubernetes cluster. So how do we do that? If you look at, I've got a deploy k8s.sh script here, and this is just convenience. You can do this manually using kubectl. The command is kubectl apply-f, and you need to give it a file that it's going to apply. So what it's going to do is it's going to look at Echo Service YAML, and it's going to determine, does this deployment already exist in the cluster? If it doesn't exist, it's going to deploy it. It's also going to check if it does exist, have any changes occurred? And if there are changes, it will apply the changes. So I'm just going to run that deploy K8s. And you notice the output of that is it has created a deployment for me. So I can have a look and see. I'll just go to a terminal. If I type kubectl get all again, now we have some more things. And let me just expand this a little bit so it's easier to read. Alrighty. So we have a pod, and you'll notice the pod is running. This is the Kubernetes service that was there before. We have a deployment and a replica set. If we go back to our diagram, remember, a deployment has a replica set which has pods. So we have a deployment which has a replica set which has a pod. And you'll notice the replica set says we have 1 desired pod. We currently have 1. So that's interesting. But if I go and I try and run my client again, I get no response because on its own, this is exposing port 8080 inside my Kubernetes cluster. So you got to think about your Kubernetes cluster as if it's another computer all on its own. And even though these pods are exposing port 8080 inside the cluster, I'm running out on my host machine, on my development laptop, and I can't drill into that. So we need to expose that somehow to the outside world. Now, with that said, it's not completely hopeless. I can see a little bit about what's going on with this pod. If you copy the pod name and you type kubectl logs -f, that's follow, and you type the pod name, you can see the logs that are running inside that one pod, which is convenient. Another little trick is you can do kubectl exec stdin tty and the pod name. And then you do dash dash, and you can run some command inside the pod directly. So if I want to pretend like I'm inside the pod, I can run bash. Well, okay, bash is a bad choice because it seems bash is not installed in that pod, but maybe I can run sh. And there you go. There you go. I actually have a command line interface into the pod. You'll notice I've got my index and a start command. I'm going to exit back out of that. I can also do something interesting. If I go to kubectl get all, remember, we have a replica set. The deployment created a replica set, and it desires one replica of this pod. I can forcibly delete this pod. I go and delete it. And by the way, this is how you can delete any entity in Kubernetes. Just a kubectl delete, and then the name of the thing you want to delete. Don't delete the Kubernetes service. Now, if I can catch that quickly, I can get all again. Well, I didn't catch it in time. I deleted the pod, but there's a pod running. But notice the ID of the pod is different. The one that I deleted had NFKKJ at the end. This has 8HQFF. And the reason for that is the replica set detected that a pod went away, and we actually desire one of them. And so it made sure that a new one was brought up. So this is kind of interesting because Kubernetes is self-healing. As long as you say, I want one replica or 3 replicas, the replica set will continue to try and make sure that you have that many running, even if 1 or 2 of them crash. So as I said before, I can't actually call this right now from outside because 8080 is only exposed inside the pod, inside the cluster. What do? Well, there is another concept called service. Now, a service can be used to expose a pod to the outside world. So in this case, I've got my deployment with my replica set with my pods. Port 8080 is exposed on the pod. I can create a service entity that itself is running on 8080 or some other port. It doesn't really matter what port this is running on inside the cluster, but I can forward that along to a port on my host. So in my case, I'm going to expose 30,080, and my host will be able to drill into this. If I call 30,080 on the Kubernetes cluster, that will forward along to port 8080 on my service, which itself will find the pod. Now, how does it find the pod? Well, first, let's have a look at what one of these services looks like. So what I'm going to do is I'm going to go and I'm going to edit the echo service YAML file. And at the bottom, I'm going to paste in a service definition. So again, you don't know what a Kubernetes service looks like. You just Google Kubernetes service YAML. You'll find an example. So this service has a name, echo service. And it's a specific type. It's a node port service. And this is important for our purposes. A node port service is the kind of service that will expose a port out to the outside world. Okay. There are other kinds of services, but that's the one I'm using in this case. Now, we'll talk about the selector in a moment, but our service, echo service, is going to run on port 8080. I could have made it run on port 8090. It doesn't matter what port it runs on. The key thing is if it intercepts a call, it will forward it along to a target. So it's going to accept something in port 8080 and forward it along to 8080 of something. So this gets a little confusing. All the ports flying around inside Kubernetes. You have to think about each thing running as if it's running in its own computer. The service is running in its own computer running on port 8080. The pod is running in its own computer running on port 8080. It's not the same port. Think about it as 2 logically different computers. If this guy gets something on 8080, it's going to forward it along to this guy on 8080. That's why I'm saying I could have run this on 8090 or 9090 and forwarded it along to 8080 inside the running pod. I hope that's a little bit clear. And then the node port, this is the port I'm going to expose because this is a node port service. So now how does this service that I'm going to create, how does it know which pod to forward its traffic to? It's going to send something to 8080. Well, the key thing is this selector. So a selector is used to query the entire Kubernetes cluster and determine which pod it's going to forward the traffic to. And in this case, the selector is using app echo service. If we go back up to our deployment, you'll notice there is a section in the spec called selector. And under that is match labels. So in Kubernetes, you can attach a lot of metadata to each kind of entity that you create. One of the kinds of metadata you can attach are labels. In this case, I'm giving my pod a label of app, and that the value of that label is echo service. So the selector goes and looks for a pod with that label on it. If it finds it, it will forward the traffic. If it doesn't find it, the traffic will go nowhere. You can think of the selector, and in my mind, the way I remember what the selector does is it's kind of like an SQL select. It's querying the entire cluster, and it's saying, do we have a pod where the label app equals echo service? And if we do have such a label, then that's where I'm going to forward my traffic to. So I'm going to run deploy K8s again here. So notice the deployment was unchanged. I didn't do anything to it, but it created a new service. If I run kubectl get all again, you notice now I've got another service called echo service running here. And the echo service is running on port 8080 inside the cluster, but we actually are opening up 30,080 on the host. So let's try that out. If I change this to 30,080 echo something and send my request, you'll notice I get a response. So here, this is telling me what its host name is. If you're eagle-eyed, you'll notice that host name is the same name of our pod. It's telling us where it ended up. Now, remember, we had said that the deployment can be used to scale the number of pods up and down. So let's change this to replicas 3. And I'll run deploy K8s again. This time, there was a change to the deployment, and it configured the change. The service was unchanged. If I run kubectl get all again, look at that. I have 3 versions of my deployment running. The replica set wants 3, and it has 3. There's still only one service because the service is routing to any pod that matches that selector. So let's go and try running that again. If I run, okay, so now pay attention to this. KPQFL. It's different this time. And it's somewhat random because you can think of the service behaving something like a load balancer. Again, it's going to forward the traffic to any pod that matches the selector. And so if we have 3 replicas, the service will forward the request to a random target of those 3 pods. That's kind of interesting. Now, just for the sake of resources, I'm going to scale that back down to 1 replica. And I'll deploy it again. We look at our get all. You'll notice now I've got 2 of them terminating because we desire 1. Now, the next concept that I want to show is what if we want something special in our running pod? If you remember my Docker video, we can volume mount files into our running container. Can we do the same thing for our deployment? Well, if we look at the index.js for this sample application, I am doing something a little bit special. I'm looking for an environment variable called myMessage. And if myMessage is defined, we will echo the message out in the response. Right now, if you look at the responses I'm getting, I'm not getting a myMessage in the response or an env message. And that's because myMessage is not defined in the environment. So what if I want to include that in the environment somehow? So this is where our next concept comes in, and it's the config map. So I'll paste that in. We've got a config map here, and a config map on its own does nothing. I'm just going to save that, and I will deploy it just so you can see it deploy. Okay, so we got a config map created, but the config map just exists in the cluster. It needs to be used by something in the cluster. But before we go and do that, let's just have a look at this. This config map appears to be describing 2 properties files. So an env properties file, which has my message, which is hello from my config map, and another properties file, which has something else. Now, of course, you can have as many parameters in here as you like. Since I changed that and I run deploy again, you'll notice the config map will configure itself again. So what I want to do is I want to get this my message from an env properties file. I want to get it somehow into my pod that's in the deployment so that my index file will read that from the environment. Now, one thing I want to show you in this particular service, if we look at the scripts directory and start.sh, this is what's run on startup for my container. It goes and checks and tries to find a file called env.properties. And if it finds it, it will source the file. It does a set -a, which what that means is when I source a file, it will keep those variables in the environment for other processes. So if the file is there, it will source the file, and anything in that file will be available as environment variables to any other process. So the index.js is looking for an environment variable called myMessage, and it wants to echo it out. It's either going to be there or it's not. After all, this is set up so that if the file isn't there, it just says, hey, I didn't find it. And again, if we look at the logs, let's just do a get all again. If we look at the logs for this guy, you'll notice on startup, it actually said, hey, I didn't find an env.properties file. So we want to wire that in somehow. We theoretically have an env.properties available on the cluster via a config map, and we need to join it up. If we look at a diagram on this, what we really want to do is we want our pod to have a volume mount into that config map, specifically to the env.properties file in the config map. So what I'll do, I'll go up to the deployment again. And right here in the spec with the container, I can define a volume mount for my container. I'll just paste this in. So I've added a volume mount to the container. It's got a name. And hey, whatever is in that volume mount, I want to mount it on run/config. Remember, that is exactly where my start script is expecting to find something, run/config. And you know, you could choose anything. And after the container definition, I can put a volume definition, and I can say, okay, well, I'm going to define some volumes, and I'm going to create a volume called config volume, and it's going to reference a config map called service config. So it's going to reference this down here. Service config has two files in it, env.properties and another .properties. So it's going to put those two files at run/config. So let's try that again. Deploy K8s. So my deployment was reconfigured, so it changed. We do a get all. We've got a deployment terminating because it's changed, and we've got a new one starting up. Now let's look at the logs for this. All right, now in this case, env.properties was found. So let's send a request into it. All right, and so we got something back, and we got hello from my config map. So that came from the config map that we had sent in. Now, just to prove to you that this really did work, let's execute into the running pod. It's sh. Remember, we wanted to mount that at run/config. And notice we have two files in run config, env.properties and another .properties. So there's my content. There's the content of my env.properties, and there's the content of my another .properties. Now, finally, if you want to get rid of everything in the end, if you look at undeploy K8s, there is a kubectl delete, and I can delete everything in that file, and that would get everything off of my cluster. And that's just if you want to clean up at the end. So, friends, I hope that this quick introduction to Kubernetes was helpful for you. Kubernetes is really, really powerful. There's a lot more concepts than what I've shown here. My goal with this video is to show you that it's really not as scary as it seems. It actually works very, very well. It's really kind of interesting to use Kubernetes. So please leave me comments or likes. Likes really matter to the YouTube algorithm, of course. I hope that I've been helpful to you, and I'll see you next time.